are going to learn about our topic number 39, hexadecimal to binary conversion. So let's move on. Hexadecimal to binary conversion. So in the previous video we have learned about that how to convert a hexadecimal into a decimal value. Now in this video we are going to learn about that how to convert a hexadecimal into a binary number. So let's look at. Okay, so here before studying the conversion of hexadecimal into the binary number, so let's revise the topic, that is number system and what we have learned so far. Okay, so in the number system we have learned that we have classified our number system into this section, or we can say this part, or we can say these categories. So number system has been categorized into this four part, that is decimal number system, binary number system, octal number system and hexadecimal number system. Okay, and we have also learned about the decimal number, that the base of decimal number is going to 10 and the base of binary number is going to be 2, the base of octal number is going to be 8 and the base of hexadecimal number is going to be 16. And we have learned the conversion of decimal into binary. Then we have learned about the binary to decimal conversion. Then we have learned about the decimal to octal conversion, then octal to decimal conversion, and then we have learned that the binary to octal conversion and octal to binary conversion, and we have also learned about the hexadecimal to, we can say, decimal conversion and decimal to hexadecimal conversion. Now in this video we are going to learn about that how to convert a hexadecimal number system into a binary number system, and that is so important also. So we are going to just learn about the conversion process of hexadecimal to binary number system. So let's look at that how to convert hexadecimal into a binary. So hexadecimal to binary conversion. So for this you have to follow this method. That is our first method, is saying us that you have to convert a hexadecimal number into a decimal number first, and we know that how to convert a hexadecimal number into a decimal number, because in the previous video you have learned that how to convert a hexadecimal into a decimal number. Now in this video you are going to learn that how to convert a hexadecimal into a binary number. So this is very simple. You have to use our first method, that is saying that you must have to convert a hexadecimal value into a decimal value. After that you can convert a decimal value into a binary number. Okay, so this is how you will convert a hexadecimal number into a binary number. So this is our first method. Okay, and our second method is saying us that the base of hexadecimal, the base of hexadecimal is 16, because we have studied that the base of hexadecimal is going to be 16, and we have also studied that the base of binary is going to be 2. Okay, and for this second method, for the conversion of hexa into binary, you know that 2 to the power 4 is going to be 16, and I am just going to use this formula for the conversion of hexadecimal into a binary number. So this is very interesting one. Okay, now so you must have to remember this rule for the conversion of hexadecimal to binary conversion. Okay, so in hexadecimal to binary conversion, okay, in hexadecimal to binary conversion, it represents each digit by using 4 bit. Okay, we have to represent each digit by using 4 bit. Okay, that is the rule which is saying us that when there is a case of a hexadecimal to binary conversion, okay, what is the rule saying us? That when there is a case that if you wanted to convert a hexadecimal to binary conversion, then you have to represent each digit by using 4 bits, and that is so important point. You have to represent each digit by using 4 bits. Okay, and you know about the bit. 0 is a bit, 1 is a bit. Okay, because you know about the binary process of the computer language, that is the computer only understands 0 and 1, and we call it as a bit. Okay, and 8 bit is going to contain 1 byte, and 1 byte is equal to a character. So you have to remember this point, that when you are just going to convert a hexadecimal value into binary, you have to assure that for representing a digit you have to use 4 bit. Okay, and that is clear for you. So let's look at the example, and we have an example that is saying us that you have to convert a hexadecimal number into a binary number. So how you will proceed it, or and we can say that how you will convert this. Okay, so this is very simple. You have to use this rule, or you can say you have to follow the rules. That is, in hexadecimal binary conversion, we have to represent each digit by using 4 weights, and this rule is going to help you in the conversion of the hexadecimal to binary. Okay, so here you are seeing a question that is saying us that I have to convert a hexadecimal number into a binary number. So how we will proceed it and how we will do this? Let's look at. Okay, here I have a hexadecimal value, we can say hexadecimal number, because its base is 16, therefore it is a hexadecimal number, or we can say its range is from 0 to 9 as well as from A to F, because we have studied that the hexadecimal range is from 0 to 9 and from A to F, and therefore this value has a range like that, therefore it is a hexadecimal number, and we have to convert a hexadecimal number into a binary number. So what we have studied in the rule is that for the conversion of hexadecimal to binary, you have to represent each digit by using 4 bits, and that is what I am just going to do it now for the conversion of this hexadecimal number into a binary number. Okay, for this you have to remember this rule. So here I am converting a hexadecimal number into a binary number. So here you are seeing that for representing a value, that is f here, because f value in hexadecimal number is 15. The number of f in hexadecimal number is 50. Okay, and if you wanted to represent a value 1 in a binary form, then you will write simply 1. Okay, so here I am just writing it, or you can say I am just going to elaborate the fact about the conversion of a hexadecimal into a binary number. So here you are seeing that this is the hexadecimal number system, and we have learned, or we can say we have studied the rule that in hexadecimal to binary conversion, we have to represent each digit by using 4 bits, and that is so clear for you, because this is a digit, f is a digit here, 1 is a digit here. So if you wanted to represent f here, you have to represent this digit by using 4 bit, and that is clear for you, I think. Here I am using the 4 digit, 4 bits we can say, for representing a digit. Here I am using 4 bits because 1, 2, 3, 4. This is a bit, this is a 4 bit, and for representing the value f, or we can say a digit, you have to represent 4 bits. For representing a digit, you have to use 4 bits. Therefore, I am using 4 bit here, because this is a hexadecimal number, and the rule is clarifying us that in hexadecimal to binary conversion, you have to represent each digit by using 4 bits, and that is what I am using. I have to represent this digit, Therefore, I am using 4 bit here for representing this digit. And because I have to represent this digit, therefore I am using 4 bit, because the rule is saying us that for representing a digit in a hexadecimal number, you have to use 4 bits. Okay. Therefore, I am using for representing a value f, because it is a digit. Therefore, I am using a 4 bit. And we know that the value of f is 15. Therefore, 2 ka power 0 multiplied with 1 is actually what? 1. 2 ka power 1 multiplied with 1 is actually 2. 2 ka power 2 multiplied with 1 is actually 4. 2 ka power 3 multiplied with 1 is actually 8. So 8 plus 4 plus 2 plus 1 is going to be 15. So this 4 bit is actually representing the value of f, and the value of f is 15. Therefore, this is representing the digit f here, whose binary contains the value that is 1 1 1 1. So this is how you can represent a digit in 4 bit for the conversion of a hexadecimal into a binary. So I have converted this value. Now I have to convert this value for the solution of this question. So here I have to convert this value, or we can say this digit. Therefore, for representing a digit in hexadecimal number, you have to use 4 bits. You have to use 4 bits. Therefore, for representing the value 1 here, I am using 4 bit here, and we know that the conversion, that is 2 ka power 0 multiplied with 1 is actually 1, 2 ka power 1 multiplied with 0 is actually 0, 2 ka power 2 multiplied with 0 is actually 0, 2 ka power 3 multiplied with 0 is actually 0. So adding all 0 plus 0 plus 0 plus 1, and that is going to carry 1. So this 4 bit is actually representing this digit whose value is 1, and this 4 digit is representing this digit whose value is 15, and in hexadecimal number, value has 15 is going to be the value of f. F value is going to be 15 in hexadecimal number system. Okay. So this is how you can convert a hexadecimal number into a binary number. So this is our final output. So this is how you can convert an interesting thing, that is the conversion of a hexadecimal number into a binary number. Because of the rule in hexadecimal to binary conversion, we have to represent each digit by using 4 bits, and that is helping us for the conversion of a hexadecimal into a binary form. So this is how you can convert a hexadecimal number into a binary form. Okay. Now let's look at the another example, and this is also a good example because it contains a decimal point also. But in the first example, we have seen only integer part. Now, here you can see a decimal number also. So, for the conversion of this number, that is the hexadecimal number, okay, that is the hexadecimal number. For the conversion of a hexadecimal number like this number, you have to convert it into a binary number. So, how you will proceed it and how you will process it, you need to consider some of the fact, and the fact is saying us, and the rule is saying us, is that for representing a digit in a hexadecimal number, you have to remember this rule, and the rule is saying us that for representing a hexadecimal number into a binary number, you have to represent each digit by using 4 bits. And that is so clear. Okay, so what I am just including and what I am just concluding in the fact about the conversion of hexadecimal into binary form. Okay, you have to use the funda, or we can say rule, that for representing a digit you have to use 4 bits. For representing a digit in a hexadecimal you have to use 4 bit. Okay, so how we will proceed? Let's look at. Here you are seeing this is an example. This is a hexadecimal number and we have to convert it into a binary number. So for representing a digit, because we have learned and we have know the fact about the rule is that for representing a digit, you have to use 4 bit. You have to use 4 bit. Here I am using 4 bit for representing a value, for representing a digit A, and for representing a digit 2 here I am using 4 bit again, and for representing a digit D here I am using again a 4 bit, and for representing this digit I am using a 4 bit again. So this is how you can convert a hexadecimal number into a binary number. Okay, so here you are saying that this all is a hexadecimal number system, or we can say this is a hexadecimal number system, and for representing a digit that is A here, you have to use 4 bits. Okay, so and we know that the A value contain 10. A value contain 10. The value of A in hexadecimal number is 10. Okay. So here you are seeing that 2 ka power 0 multiply with 0, 2 ka power 1 multiply with 1, 2 ka power 0 multiply with 0 is actually 0, 2 ka power 1 multiply with 1 is actually 1, 2 ka power 1 multiply with 1 is actually 2, 2 ka power 2 multiply with 0 is actually 0, 2 ka power 3 multiplying with 1 is actually 8. So 8 plus 0 plus 2 plus 0 is actually 10. So this 4 bit is actually representing this digit, because the value of capital A in hexadecimal number is 10. Therefore, this 4 bit is actually representing this digit. And in the same way, we have to represent this digit again. So I have to represent 2 digits. Therefore, I will use 4 bits again. 4 bits again. Therefore, I am using it. So 2 ka power 0 multiply with 0 is actually 0. 2 ka power 1 multiply with 1 is actually 2. 2 ka power 2 multiplying with 0 is actually 0. 2 ka power 3 multiplying with 0 is actually 0. So 0 plus 0 plus 2 plus 0 is actually 2. So this 4 bit is actually representing this digit. Okay. Then after that I have uses the decimal point. Then again I have uses the formula, or we can say the rule, and the rule is saying us that for representing a digit, for representing this digit, you have to use 4 bits. Okay. So again I am using this concept. Okay. Okay. So D here, and we know that the value of hexadecimal, the value of D in hexadecimal is actually 30. Actually 30. Therefore, 2 ka power 0 multiply with 1 is actually 1. 2 ka power 1 multiply with 0 is actually 0. 2 ka power 2 multiply with 1 is actually 4. 2 ka power 3 multiplying with 1 is actually 8. So 8 plus 4 plus 1 is actually going to be 30. So this 4 bit is actually representing this digit whose value is going to be 30. Okay, because the value of capital D, or we can say D in hexadecimal number, is going to be 30. And in the same way we have to represent this value again, or this digit again. So I have to use 4 bit again. Therefore I have used this bit. So 2 ka power 0 multiply with 0 is actually 0. 2 ka power 1 multiply with 1 is actually 2. 2 ka power 2 multiplying with 0 is actually 0, and 2 ka power 3 multiplying with 0 is actually 0. So adding all this term, 0 plus 0 plus 2 plus 0 is actually 2. So this 4 bit actually representing the digit that is 2 here. So this is how you can convert a hexadecimal number into a binary number. So this is very simple concept, and the rule is clarifying us all the concept that how to convert a hexadecimal number into a binary number. So this was all about the conversion process of a hexadecimal into binary. So thanks for watching.